Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. In this video today, we're going to take a look at arrays, we're going to look at file input, we're going to eventually change the arrays over into vectors, which are just fancy, smart arrays. And once you learn vectors, you probably will never use arrays. Well, you'll use arrays occasionally, but vectors are the way to go moving forward, at least in C++. And this is part of an activity. This is activity 8, I believe, from the CIS2541 class. And so I'm starting off with this giant splotch of code, 60 lines of code here. And the goal of this code right now is to take input data from a user, put it into an array, and then process that array and find the average score of all the scores that you put into the array, find the highest score and the lowest score. So starting out, I'm going to need IOStream to get this thing working. And then these are function prototypes, which means that these things are defined below, and we'll get there. I'm going to talk through everything as we go, of course, as I always do. And so they're defined down here, but if I use them up here, the compiler needs to find that information, and it's kind of confusing, but the reason for the prototypes here is because the compiler reads our file from top to bottom, and if you put something down here like find average, like this right here, if this isn't defined up here, this is like a placeholder. This is telling the compiler, hey, eventually you're going to find a definition, you're going to find the actual function called find average, but just trust me, until you do, it's going to take two parameters. It's going to take this grade type, which is an integer array, and it's going to take the size. It's going to take like an integer array and an int as parameters, and it's going to return a double. So just trust us on that. Trust me. And that's what these things are here for. Because if these things are removed, when you get to this point, it doesn't know what find average is, and you get a compiler error. That's the whole reasoning. And like I say, you could put these functions above. You can move all of these above the main, and in this example, it would work. But a lot of times you'll find that, as you get to more complicated examples and you create more complex programs as you advance in your career, you will see that functions call other functions, and at a certain point, it'll be impossible for function A to call function B without function B needing some other function. You'll never be able to order the functions correctly so that you don't need a function prototype. So it just makes sense, just so you understand and you use them. And as we move into object-oriented programming as well, you'll see that we'll use these less and less. But occasionally, you do need to use them. Okay, so let's talk here. So I'm starting out my program. As I was saying, I'm going to need an array, and here it is defined. Int grades 100. It's saving 100 spaces for data. 100 integer spaces. 400 bytes of memory are being reserved, and every element in this array is 4 bytes. And one thing we do have to remember, because especially as we're getting introduced to computer science terms, is that computers start counting from 0. So if we're going to say, like, what is the first element of the grades array? That's going to be the 0th element inside the array. And so humans generally start counting by, from 1, 2, 3, 4, 5. But computers generally start counting from 0, 0, 1, 2, 3, 4. And so it's a shift of 1, but that's where a lot, especially introductory level stuff like this is, that you get what we call off by 1 errors, where you think that you're dealing with the first element, but you're truly not. Or you think you're dealing with the last element in the array, but you're truly not. And you get some problems. And so you always have to look out right on the edges. Those are your edge cases. Those are your test cases to make sure everything's working properly in those cases. So when the program starts off, there's 100 elements. These things are uninitialized, but if I put this little curly brace like this, it'll initialize every element to 0. I know it's stupid, all the little syntax things. C++ is famous for having all these little syntax things that you don't necessarily know about, but can cause great problems later on. So if you don't want to initialize, just leave it like this. But if you wanted everything initialized to 0, put the little curly braces there, and it just tells the compiler to add zeros. The number of grades, of course, is going to be 0 because at the moment there are no grades. Actually, I'm going to move this down here, and then as we go, we're going to, like, because the first part of this is our input stage, correct? So it's input, then process, and then they always like to see, you know, they teach us we're supposed to be combined, you know, that we're supposed to separate input, process, and output, but they don't actually do that. So I'm going to move this down here. Well, I'm not going to move it down here now, but we're going to move it down later. We're going to do the input, which is up here, do the process, and then work our way to the output so we can separate things and do things better than the teachers of the book do. Okay, so position is 0 because, again, if I'm going to put data into this grades array, like this, grades position, it better start out as 0. So this is a 0 to start. Why don't I just put 0 there? Because it just makes more sense as we're going to go through this. So input a grade from 1 to 100 using a -1 to stop. And then I input the data. And if I do put a 0 right off the bat, or I'm sorry, negative, I changed this around a little bit and then I forgot. -1, -1, sorry about that. I'm already 6 minutes in, so I'm not going to start that thing over. I don't do jump cuts or anything, generally. But anyway, so if I put a -1 in for a grade to stop, and why can't I have a 0 grade? I don't get that, so I'm going to put that in there. You get a pity point? No, no pity points. You get 0. Zeros are earned, generally speaking. So, when I input a grade from 0 to 100, I add put in a -1 to stop. And if I do put a -1 in right away, it'll come right around. I will not input any data whatsoever, and the number of grades that were put into this thing will be 0. And yeah, and that can actually be quite a problem. So let's go ahead now and just kind of work this out. So using our while loops, we're kind of combining everything we know into one example right here. So it says, while I don't input that -1, what do I want to do? Well, at this case, the value is already put in there. So maybe. So the grade is already put into this location. And if it's a -1, it's a -1. But the position needs to increase for the next time. Next time I ask for your input, because this is what we call the priming read. We get the data, we put it in, and then we check. Hey, okay, cool. Are you -1? Yes, we're done. We don't, and then otherwise we add on and we go, oh, okay, now since we increment the position, that means there's at least one element now, and then we ask for their information a second time. So let's run this. Don't worry about anything else here. Just worry about, let me put a breakpoint in right here at 23. Okay, so I go, please input a grade from 0 to 100, and I put 9, and then I put 11. I'm not putting in actual grades, I'm just putting in numbers. 12, and then I put in my -99. I'm sorry, -1. And then you can see here, now looking at this stuff, I go over grades, and it goes, there's my array. 9, 11, 12, -99, -1. Those are the values that I typed in. And so the array is actually holding the correct information minus my mistake. Let me just run through this one more time. 9, 11, 12. I keep -1. Okay, now you can see a little bit better here. So there, oops, come on. There we go. And then so 9, 11, 12, -1. And then the position is 3. Which means that we've entered 3 valid pieces of information. There's my 9, there's my 11, there's my 12, and the -1 is not to be used as part of any calculations because that was just used to tell use the sentinel value to tell the loop that we're done inputting data. So this is pretty much everything we need to get the input stage going, because now we have the data and then position. The last thing I would want to do here is just say, as part of the input stage, is to say, okay, this number of grades is equal to the position, because that's the number of grades. Position ended up being 3, right here. So that means the number of grades is going to be 3. And so one thing I'm going to do just to simplify this just a little bit, now that you understand the process, is to take position and just replace it with number of grades. And remove all of that and one more time. Number of grades. Because as you could see, that it's by just setting that one number equal to the other, then we don't really need it for anything. because we don't need that extra data because it's already contained inside here, the number of grades that have been input. So that covers the input stage. We have everything we need now to take that data, because we know the number of grades, we know the grades, we have the array set aside, and now we can do all the extra work to get the job done. Okay, so now the calculation stage of things. So the first one is given to you. Double average of grades is equal to find average, grades, number of grades. Grades is the array, number of grades is the integer. And just like we saw above here, everything matches up. The two parameters match. Grades is my integer array, size is my integer. And so you can see also down here, the function is already done for you. You don't have to worry about that. You can kind of see, and I changed things up a little to be a little more consistent with best practices as opposed to C-style code. And so you can see here again, there's the return value, there is the first parameter, and there's the second parameter. So if I'm going to find the average of all the values, I have to sum up all the elements and then divide by the number of elements. I mean, that's just what finding an average is, finding a mean. And so just to get things going here, I'm going to say, okay, my accumulator is going to be set to 0 to start out. And that's an integer value because every element in here is an integer. So I'm going to add up all the integers. And so now I'm going to for loop. I'm going to go through every element. I'm going to start from 0 again, remember. Computers count from 0. And I'm going to use that size, which is in this case is the number of grades. I don't want to process all 100 because we didn't use all 100. Most likely you didn't use all 100 grades. You only used 3 or 4 or 10 or 20 or whatever it is that you used. But if you tried to use all 100, especially if they're all 0, your average isn't going to come out right. So by passing in the 3, this is going to go and say, okay, get me element 0, get me element 1, get me element 2. And then when it goes up to 3, because 3, the position will be 3, position is not, will not be less than 3. 3 is not less than 3. It'll break out of the loop and it'll have processed everything appropriately. So then it says, okay, get me element 0 and add that to my accumulator. Get me element 1, add that to my accumulator. Get me element 2, add that to my accumulator. And then the 3 will kick me out. So when the loop ends, I will have had all the elements added to this accumulator, and now all I have to do is divide by the number of elements, which was given to us up front by the size parameter here. And the only thing here is just to make sure that we don't lose precision, because sum is an integer, size is an integer, and if I just return integer divided by integer, I'll get a double, but it'll be integer division and it'll cut off the fractional part. So I have to make sure that I cast one of these two values into a double to do the calculation correctly, to return a double properly. So this is everything we need to know. So this will generate an average. Here, let me just, now that we have that discussion done, completed here. So if I make 9, 9, 11, 11, and -1, it'll print out 10. The average of all grades is 10. And right now we don't have anything for the highest grade because we haven't done that right. But the average is 10 because 9 plus 9 plus 11 plus 11 divided by 4, quantity is 10. And if we wanted to, because there's no reason not to, we've already talked about this, if I use iomanip, I can work this down here as the average of all grades, blah, 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 is to say that I can add this right here, right before the output. I can add the fixed, and then I can add the set precision. And so now I can run this. Let's do this one more time just to show 9, 9, 11, 11, and now it prints, oops, -1, and now it prints out 10.00. It gives me the 2 decimal points in case I need that. And so last thing here, just to get, for this average of grades part, is that, as I was saying earlier, you generally want to remove the output and put it in its own section. So right now, this is the only thing that matters, the calculation part. And now, then we'll output everything later on. Okay, so now, final 2 steps here. We need the highest grade and the lowest grade. And I won't copy paste from down here. I'll work it through a second time. But what I want to have happen here is, and these return integers, these don't return doubles, is to say, okay, the highest grade, I just got to make sure I find the correct function here. Find highest, that's the name of it. Find highest, and I'm going to pass in the same data. Oops, added a semicolon, and it added, okay, removed some stuff there. Okay, so that's what I'm going to want to be able to do. Get me the highest grade for using this function from this array and this number of grades, and it'll get that for me, and it'll save it right here, and it'll print here when it's done. And again, I just want to come down here and put it in here. And then we'll fix up the lowest grade after we're done with all of that. And so now let's go ahead and do that. So we've already talked it through, and with the example shown to you, but now let's do that without having that information. Let me just see you stop staring at it here. Let me get it out of your way here so we can talk about it. Come on, come on, there we go. So we can talk about it without having it visually on there on the screen for you. Let me make this a little bigger for you. Okay, so what am I going to do here? There's a possibility. So there is a possibility that the highest grade, or there aren't any grades entered, because remember, as we discussed earlier, I will go up here. If the first time you enter any data, you enter -1, then you have 0 grades. So there's nothing to test. And that's kind of a problem, and I don't even say we can discuss this later when we deal with this kind of stuff. But what happens if there is no size? I mean, that isn't a legitimate problem with this program. What happens if I run? Oh, I can't run this anymore because I jacked it. Oops, I jacked it again because I go too fast when I'm thinking and typing. Okay, so if I just put a 0 in here, what happens? I put a -1 in to start. And now you see the average of all grades is not a number, NaN, because it didn't do the math right. So that's a legitimate problem. And right now, you'll see here in a minute, let's just do it the way we think it should be done, and then let's just see what errors pop up if we have that kind of case going in here. So I say, okay, let's just say that the largest, we'll call it highest, because that's what they use. Let's just say it's a -1, because that value is technically outside of the range of things that you should have, because it says the computer or the prompt says input a number from 0 to 100. So that technically should not be any of the things going on. But I want to check every number for int, and I like to use I. I don't like to use anything. I = 0. I is less than size plus I. So this is exactly like I did up here before. It's a start from the 0th element and go and tell me every element, or we're going to go through every element in the array. And if the array at that I value is greater than the array at the highest value, oops, oh, I guess we have to put a 0 here. I hate when I do things differently than other people do them, because by the time I catch on, I make mistakes and, you know, that sort of stuff. But anyway, I digress. So the highest value will be at index. Oh, wait a minute. Yeah, we have to do things this way. The highest index, oh boy. Yeah. Okay, so let's just think this over one more time. So, okay, so this gets me the array at the highest index, which is the 0. And this will get me whatever's at the I index, in this case 0. And so right now we don't have to worry about anything. But if this was true, then my highest value is going to be equal to my I value. And then, so what does that mean? I know that's the key. Like, what are you talking about, Brad? And I will admit, since I haven't been in front of students 20 hours a week for the last year and a half, that explanations get a little janky. I'm trying my best. I'm a little rusty here. I used to do this a little better. But this says, for every element in my array, check to see if the value in that array is larger than the highest that we currently have. And if it is, store that. And so as we go on through the entire array, what happens is, because we're not storing the highest value, we're storing the highest index from where the element is stored. So this, whenever we get through this entire loop and go, hey, what's the biggest element? What's the biggest element? What we can do here to return the highest element is return array at the highest location. Because again, if I just returned array, or if I just returned highest, I'd be returning an index value. I would not be returning the value in the array at that index value. That's a big difference here. And so what happens if there's only 0 elements? This will return 0. And you'll be like, that's confusing. That's what's... So in this case, I go, okay, input a grade from 0 to 100. I'll put a 9 in, I'll put a 9 in, a 10, a 62, a 12, a 91, and then an 85, and then a -1. And it goes, there we go. The average of all of this, not including the -1, is 39.71. And the highest grade is 91, which it was. And that's the integer value. That is the largest value. And you could test this. And so the things I would test is, what if the largest value is the first value? And it works. What if I do the last value? And it works. And then again, the final one, what happens if I put 0 or no values in at all? And they go, okay. And that's a problem here, because what's happening here is I'm returning the -1. I guess that's fine. It's one of those things, should you expect that? And maybe you should, because if this is coming out with crap data, then this is going to come out with crap data. And because the user put a -1 into that spot from the loop inside of main here, then since they did that, then it makes sense for it to print out the -1. And so, okay, so I guess I'm a little happier with things. I don't like that it doesn't tell me outright that, you know, things are good or bad or whatever, but we can fix this in a minute. We can fix that all up here. And so, get rid of this end line. Don't like the look of that. Okay, and then I can put the end line here instead, so everything looks a lot nicer. So now let's finish up and do the exact same thing for the lowest grade. This should go a lot faster because I can copy paste. Should always try to do the, we're lazy by nature here, us programmers. So what we want to do is find the lowest grade. And what we can do here is take our code here. I can bring this up now that we've talked twice through all of this. I can steal this guy, and I can put it in here. And of course, there's really going to be only two differences. One is I'm going to rename this guy so I don't have to call it lowest. And apply. There we go. So now everything is lowest, but now instead of greater than, I'm just going to apply a less than. That's it. But also the highest value, or the lowest value, nothing's going to work right as is. Let's just try this. Let me show you. Like, if you just copy paste, like some people do, you're not going to get what you think. 11, 5, 4, 6, 8, -1. Oh, we don't even have an output yet. The highest grade is 11. I didn't even notice that, and we have to do that as well here, and so we will. And we'll say the lowest grade is, and I'll add one space here just so it's a little better, and lowest grade. Now try that again. Just put in random numbers. 8, 4, 6, 1, -1. The lowest grade is 1, and it just happens to be just happened to work right. Array I less than array lowest. Oh. That works? Interesting. It actually works. I wasn't expecting that. Because the lowest index, because it's lowest lowest value. It seems to be working. So let's just kind of stay with it. I was expecting it to give just a nonsense answer. So let's just try out all the cases here, because that's programming is testing. It's more testing than coding. So if the smallest number is the first number, it prints out that correctly. The highest is 8, lowest is 2. Okay. And so what if now it's the last number, 8, 7, 6, 5, 4, 3, 2. 1 and -1. It prints out the correct stuff both times again. And one last time here, what if it's in the middle of a bunch of values? It still works. So yep, our testing seems to say that this is a working condition for us, which is great. And so now that all works for us. Everything prints out properly. But now the final thing is, since we've tested out the highest numbers, the smallest numbers, the average numbers, that sort of thing, is again, if I put a -1 in here and this all comes out like this, what I could do here is just to say if the number of grades is greater than 0, then print all this stuff out. Otherwise, what I would like to do no grade data entered. And then just call it that and call it a day. Or just say nothing to compute or something like that. It does not compute. So now I feel a little better about things now. Instead of giving the user garbage data and having maybe someone think, oh, that's correct, and have them write down incorrect stuff, if I start off with a -1 right off the start, it says no grade data entered, nothing to compute, and I don't have to worry about that anymore. And as long as I enter any data whatsoever, you will see that everything should come out properly, and this problem should be complete. And you can't enter more than 100 numbers. I'm not going to go ahead and do that. But you can see now there's my average, about 7.54. I'll trust that. 16 and 1. Let's just put in, let's put in 5. Let's put in 7 numbers. 1, 2, 3, 4, 5, 6, 7. And I should get 4 for my average, and I do. So with all the testing I've done, how much of a guarantee can I give you that this is correct? I can give you 99%. I can get, everything we've worked so far after we fixed everything up is working. But I would need more testing before I would guarantee I'm going to put this out into something, especially with all the hemming and hawing I've been doing getting this thing to work myself, trying to set it up so it agrees. And that's part of programming too, is you're going to have to learn like this. You're learning to code and work your code in with other people's code. Especially when you're a brand new coder, when you're out in the world, you're the junior coder, you're going to be the one working with other people's code. You're going to be the one just kind of trying to make things work. But as you get, right now you're writing your own code for most of it in these courses. But eventually the only time you'll do that in the future is when either you're the only one working on a project or you're the senior members of the team and you're the ones developing all the complicated high-level stuff like the engine of your company, and then the other junior developers are working with that. So it takes a while, and it's a skill that I didn't really understand until I got out in the world, that I know C++ very well, but I don't know how other people think. That's always going to be a problem. Okay, so that covers the majority of this. Now we're going to work into the file input into this, and then for anyone who's interested, we're going to also, whoever is even still with me, if anyone even watches this, we're going to follow along with the vector and change this all into vectors as well. Okay, so the main difference is, since we've separated everything, here is our input stage. Everything that is here is our input stage. Here is our calculation stage, and here's our output stage. Now that we know that we're going to be changing this over for file input, then we know it's input. All we have to do is modify the information here, get the data into the array from the file, and then everything else will work properly. Garbage in, garbage out, but as long as I get the data from the file properly, then we'll be good to go here. And so I'm going to set up a file. I don't know what they call it. I'm just going to call it data.txt, add new item. I'm just going to call it data.txt once it gives me a moment here. Okay, data.txt. And I'm going to put information in. I'm going to put 9, 9, 11, 11, 10, 19. I'm just going to just random stuff. And I'm not going to put any spaces after the last data. I'm not going to even put in -1 or anything like that. I'm just going to say 9, 9, 11, 11, 19, 72. That's my data. I'm going to save it. I'll leave it open here just so you can see it. And so now I'm going to, instead of getting the input from the user, I'm going to need that input from that file. So first thing I'm going to need, because I know I'm using a file, I'm going to use fstream for file stream. Okay, so yep, that's good. All right, so now I can kind of rework this. I don't need this anymore. I'm going to need to open the file, so I'm going to say, okay, input file stream. I'll call it file, and then I'm going to call it data. I'm going to hard code it to data.txt. Okay, so I'm going to open it, and one thing I'm going to do is I'm going to do my check here. If file.fail equals true, or actually, if it's false, if it didn't fail, and then I'm going to put everything else in here. I'm going to move everything down, add a right here. And if it did fail, then I'm going to print out file did not open, file not opened properly or something. And call it a day. And just to show things are working here, I'm just going to put data1.txt in here. And it prints out file not opened properly. And if I put data.txt, it should, I don't know what's going to happen, but it should not print out that error. And it good, phew. Okay, yep, and now it works in because it opened that file properly. Okay, so now what we're going to do here is change this up and say, instead of saying while the grades entered is not -1, I'm going to say while file.eof, end of file, equals false. While we're not at the end of file, what we're going to do is we're going to put the data in at grades. We're going to go from file, and we're going to put that data, the next splotch of data that goes in is going to go into grades at the number of grades position. And then I'm going to increment number of grades because it needs to move over to the next element. And then I'm just going to kick that out. Get me data, put it in. Get me data, put it in. Get me data, put it in. Oh, enter file, done. That should do it. I talked for 20-something minutes about all the other stuff, but it should only be 3 or 4 minutes here. Let's see if that did it. Oops. And so now there we go. The highest grade is 72. The lowest grade is 9. And average this thing out. Let's see, 91, 100, 100, 18, 29, 40, 59. 131 divided by 6 is about 20, almost 22. So yeah, it is correct. So it did everything. It took all the data from the file, and that's all we had to do here, right? And I got to make sure I close the file as well. So I can do that down. I do that down here. File.close, just to be safe. Do that after you use the file. Because I could either open it and use it, or it could close, and I wait until everything is done to say, okay, file.close. Open file, test file, use file, close file. Those are the four way test that it opened properly. And so you can change the data in here now however you see fit. Let me just get rid of this and run it again. And now you'll see with no other jiggery pokery, now it prints out the average is 10, the high is 11, and the low is 9. All right, cool. So that works. We got that going. Let me bring this back over here so you can see it one more time. Only this, basically this stuff right here is what we changed over. That's our input stage right now. And here's, again, we didn't touch the calculation stage, and we did not touch the output stage. Okay, so now if you're interested, we're going to change this over, get rid of arrays altogether, and now use vectors instead. All right, so if you're not familiar with vectors at this point, then you're going to see what I add and whatever, but you really should spend a couple minutes and just look through, just find a quick little some documentation on vectors so you can see, because we're going to definitely cover this. We covered this especially in advanced C++ to death, because vectors end up being the data type you use so often. And so we're just going to try to retrofit this thing and go, okay, now that we know about what a vector is, let's go, now that I know what an array is, I did all the code, but now that I know the better way to do things, how would I go back in and fix everything up? And so this int grades 100 can be replaced with, and I need to include vector here. Can't do much of this without the vector include. So I can say, okay, I can change this up and say, okay, I want a vector, which is just a smart array, but I want to use the integer data type. And those are the angle brackets. They call them chevrons. I didn't learn that until recently, like within the last couple months. And so now I can say grades. And I don't need to set I don't need to change and set anything here. I'm going to delete this. And I don't even need the number of grades anymore, which is going to be really cool. I can show you. Let me just get rid of that. Okay. So all I need here is std vector of int called grades. And it will initialize, and it will know it has a size of 0, and it will have no elements inside of it, which is what we, basically everything we did manually, in the last 20 minutes or so. And so now, coming into the input stage, how do I get data into it? Like this is, you can't do it in one line of code. So I have to say, okay, get me an integer value, and I have to say what value is coming in. I have to go into that. I have to, put the data into the value. I don't even need number of grades plus plus again. But what I need to do now is say grades.pushback, push back, and put that value in. And so again, I've been saying, and if you look into the documentation, a vector is a smart array. And so by doing this, it increases the size manually, and it maintains the data manually as well. So everything is done for you, and it just puts the value in place. So the 9 goes in first, the 9 goes in next, the 11 goes in next, the 11 goes in next. And there's no data because we didn't change this. We didn't change the way the file is being read. We've only changed the way that the data that comes from the file is put into a data structure here on the program side. So that is all there is to the input stage of things. And if we go here, it won't let me run anything. But if we did run here, you would see that those grades are in the vector just the same way as they would be put into the array. And so now we need to fix all of this stuff up here because because we're not using arrays anymore. And what I can say is I'm going to pass a const vector of ints, and I'm going to call it array. And what I'm going to do here, just to be safe, is since we've talked about everything up to this point, is put a little ampersand there. And I'm going to replace all 3 of these like this. And I just got done grading the advanced C++ class, and many students, and I have warned them over and over and over again about this little ampersand, their program, instead of running for 30 seconds, runs for many, 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 many minutes. And all they did was forget this one little ampersand. And remember, this means pass by reference. If I pass a vector by copy, by value, it's making a copy every time I pass it along. But all I want to do is go through the data and look at the data. I don't need a whole separate copy. I just need to go through it and use my little finger and just go through and go, oh, that's a 7, that's a 9. Like, I don't need to make copies to be able to do that. You just need to be able to, access that and look at it. And by making it const, it makes it so I can't accidentally go in and change things. Because basically, I'm holding the ledger while you're reading it, and basically I'll slap your hand down if you try to change anything. But I didn't have to make a copy, which obviously is more efficient than going to the copy machine every single time you want to borrow it, and then here you go. I mean, it's just wasting time, wasting effort, and wasting resources. It's pretty much how it goes. So now by passing by const reference, now everything is going to work the way I expect it to. And don't worry about all this. We have to fix it down here as well. Let me steal this guy one more time just so we have it. Okay, let me find the 3 functions. And what's cool about this is, you'll see here in a second, I'm going to replace this. And this is the joy of the architecture. The people who made this are very smart people. It should work now. It should work exactly the same. Rebuild failed. Let me see what failed. I've been tinkering with a lot of stuff here. Number of grades is undefined. Okay. And so yeah, I forgot about this part too. So when I'm passing this vector along, it passes all the data, but because it knows it's a vector, the API, there's code behind this vector that tells me it knows the size of it. So I don't need to only with an array do I need to pass along the array itself and the number of elements I need to process. But for a vector, I do not need to do this. I thought it was going to work, but it didn't. And you'll see things are breaking. That's fine. And so what I need to do to fix this is to say, I can't just say size, but I can say array.size. And then put in the little braces here because it's a function now. And every time I see size, I'm going to put that in its place. And it goes throughout all these functions, everywhere you see it, everywhere it's broken. And so now let's see what happens if I rebuild. Maybe I have something else going on. Oops. No, oh, I need to call this without the parameter. I'm fixing this up. Okay, fair enough. All right, so now number of grades is undefined. We're getting closer. We really, really are. And so now what I can say here is if what do we call it? Grades. Grades.size. I just said anywhere I use that. So now if the grades has more than 0 elements in it, it'll print this. Otherwise, it'll print that. So now where are we? And now we just have size unsigned, 3 warnings. 3 warnings. And that's because down here, these are meant to be unsigned. Anytime I'm using that function, these are meant to be unsigned. And so I'm just teaching you this because I tell you guys, warnings, treat warnings like errors and you'll never have an issue. And now I have 0 errors and 0 warnings, and now I don't know. Let's see what happens. Do I get my 10 again? And I do. My 11 is my high, my 9 is my low, my average is my 10, and I can put different values in and just call it a day. And I don't even need to worry about the -1 anymore. And now my average is 31, my high was 98, my low was 9, and we're done. And so one thing is, the one thing that didn't change in all of this here was that I can access a vector the same exact way as I can access an array by using the square bracket notation here. Everything else kind of needed to get modified because it needed the size from the array itself, but everything else that actually accesses it is exactly the same once you get it going. So let's see, is there anything else that we need to talk about? Because that covers vectors, const reference for sure. Learn that. Like I said, if you learn anything, pass anything larger than an int or a float by reference, constant up if you have to. Save processing power on the back end of this thing. So let's see. I set up the vector. I opened the file. We got all the data into the vector, and then we processed it exactly the same. Using the same methodologies, just changing it up just as we needed to make this thing work. And I think we can call it a day here. So if this is a pretty long video, and again, I'm a little rusty trying to explain things, so I feel like I'm not explaining things as well as I could in other videos, so I apologize for that. So if you have any questions or concerns, or if I misspoke or anything like that, please let me know, and I will correct things, and I will get back to you as soon as I can. So you can get to me, swardb@cod.edu, or you can definitely get a hold of me as well here on YouTube, and I will get back to you as soon as I can. So let's see, moving on. So now that we're learning arrays and we're learning vectors, the next step is basically sorting and searching, basically applications of arrays and vectors. And that's a huge one, sorting data and processing data. That's why we have computers. So it makes sense we're going to cover that in the next chapter. So I hope to see you there. No matter what, hope you guys have a great day. Take care. Have a good one.